Hey, what's up, everybody? Want to talk to you guys about Ohm's Law Lab 2. That's not the right one, though. Here we go. Ohm's Law Lab 2. So, this is our question sheet. Um, I'm going to first walk you guys through how to set up and start all of these ones in the top here. I'm just going to do the first one, but that'll help set you up for as you move on. Then I have two examples for part two as well that I can show you also. All right. Um, so once again here, up here in the directions are always important. I always try to put the important information up there. You're going to set up the following circuits in Tinkercad. You're going to need a power supply, a breadboard, an LED, one or two 1 kilo ohm resistors, and some black and red wire. So right here, I am telling you what you need to search for to find in Tinkercad. So let's start pulling that stuff in to begin with. Okay, so we need a power supply. I'm gonna grab this thing right here. Okay. We need a breadboard. No, I always do that. Breadboard. Boom. Okay. We need an LED and we need some resistors. And we're going to need some wire. All right. So first of all, we need to connect our power supply up to our breadboard. So we're going to use our buses today for that. So I'm going to connect a red wire from positive to positive, a black wire from negative to negative. And again, now we're going to have the negative string goes all the way down here, the positive string goes all the way down here. All right. So for circuit number one, we're going to set up a series circuit with an LED and with a 1 kilo ohm resistor and a variable power supply. That's what that is right there. So here's my 1 kilo ohm resistor. I'm going to throw that could be in my positive or my negative, doesn't really matter. To start with, it's just going to go to the opposite. We're then going to take my LED. I'm going to connect that up. Okay, so it's sharing the same path there. So again, here my electrons come, they're going to come down this, they're going to go through this resistor, through the LED, then they're going to take a wire back to the positive end of things, all right? And if I start my simulation here, I have my LED, it's on. Now, let's say that your LED didn't turn on. That would be because your polarity is backwards, okay? So if you go to set this thing up and your LED does not turn on, notice there's no amperage running here. So we're going to hit the R button to flip it around again. Okay, the anode LED, the anode side of the LED is always going to go to positive. The cathode side of the LED is always going to go to negative. Okay, so that's the actual way that you figure this thing out. We're going to start our simulation again. So over here, this is our variable power supply. And in the question, it says, okay, start at 0 volts, increase the voltage. What happens to the LED and why? Okay, so you can see what's happening both in voltage and in amperage here. Okay, so that's pretty handy to have. Also notice that once it gets to a certain brightness, the LED has this exclamation mark. That means that the amperage is way too high and it would blow in real life. And it way too high, too much. Not bad, yeah. So anyways, that would be the first thing, right? And again, to go back here, you would start to answer the question, start the power supply at 0, slowly increase the voltage. What happens to the LED and why? And I want you to answer in language specific to Ohm's law. So once again, I have things that are including but not limited to things like voltage, current, resistance, inversely proportional, directly proportional, increase in EIRR, decrease in EIRR, etc. Okay, lots of different things. You're also going to answer in full sentences. Okay, so that's part one. So that's good there. Part two, you're going to calculate the resistance and the current. So you're going to have to use Ohm's law to calculate current, but before you can do that, you need to calculate total resistance for two series circuits and two parallel circuits. Despite the fact that these things look a little different maybe than what we're used to, the electrons still come out, they separate, they come back together, they go back to the battery again. Okay, so despite the fact that they're different, it's still parallel. I've created two separate examples here for us to kind of follow along with. One series, one is parallel. Okay, so in series here, first I'm going to calculate my E, my I, and my R. So remember, we have E over I times R. And like I said, I always write that at the top of my Ohm's law stuff. So first of all, for example number one, which I have not included in the sheet this time, so hopefully we don't have that confusion anymore. But for example number one, now I've forgotten what my resistors are. My resistance total, I still need to figure that out. It's a series circuit. So that's 500 plus 100 plus 400 is equal to 900. And I've made these numbers easy for myself here. So my E total is equal to 9 volts. And then my I total, that's the question right now, right? So we're looking for I, we cover up I, it is voltage divided by resistance. So I is equal to 9 divided by 900, which should be like 0.01, I think. Yeah, 0.01 or 10 milliamps. Okay, so I need to go through and I need to set this up in my circuit, and I need to measure resistance, and I need to measure current. So let me set this up, and then I'll kind of come back to you and show you what I'm doing here. All right, so here I have gotten rid of the power supply, and I've brought in a 9-volt battery. I just started to type battery. Here's 9 volts. I have just connected this directly to the power. You could also connect wires to it. Doesn't really matter. Just make sure black is going to negative, red's going to positive. So again, this is going to be a series circuit, and we need to measure current, and we need to measure resistance. So let's first put these in series, and then we're going to worry about connecting them up to the battery and whatnot after the fact. So here I have, this starts here, it comes across here, it comes across here, it's over with, right? So let's bring in a multimeter. And while I'm at it, I'm going to snag two of these. One of them is going to be a resistance multimeter, and one of them is going to be an amperage multimeter. I always want to like push the button. Anyways, so let's check our resistance first. So remember, do not really just like strap this thing onto the board, hold it off of the board so that these connections are outside. We're going to connect one wire to like one side of here. Okay, that's going to be my black test lead. We're going to connect another wire to here. That's going to be my red test lead. If I were to start my simulation, I'm reading 1 kilo ohm. Which one of my LEDs did I calculate this wrong? Oh, 300. Whoops. My calculations there, I said that it was 400. My bad. So anyways, let me That's my 500. That's my 100. That should be a 300. Okay, so now I'm right. So again, this is why, one reason why it's important to like do the math, check your work, you know, because if things are off, you can see it pretty easily. I'm going to stop my simulation. So the next thing here, if I wanted to run power through this, and if I wasn't really concerned about like measuring my amperage, I could come through here and start my simulation. Notice that my resistance has stopped working. So you're not going to be able to show me a resistance, which is fine. I really more care about the amperage. Resistance stops working when you put power to it because it's getting powered. It won't work any longer. So let me show you the wrong way to connect up a ammeter. If I were to connect up between here, oh, I got to stop my simulation. Why don't we move this one over? If I were to connect in parallel, which is the opposite of what you're supposed to do, and if I were to connect this up like this, and I went to go start my simulation, this is saying that we're getting 5,000 amps of power, which is not possible. So what's happening here is electrons are coming through, and remember, they're going to take the path of least resistance. In this case, the path of least resistance is going through the multimeter. You're creating a short circuit. All of the power is going through the multimeter, coming out, coming through here, and coming back again. It never enters any of these resistors. It completely bypasses them. So that's not good. That is not what we're looking for. That's not the right answer. Stop our simulation. We need to connect in series. So let me show you how that's going to work. Randomly, nope. I want you to randomly, I guess it won't let me randomly connect something. So let me just delete. So what I'm going to do is I'm going to disconnect the circuit in some way, shape, or form. Okay, so I've disconnected the circuit. If I go to start this now, I will read my resistance, but my power has stopped. Now I'm going to, so this is my positive lead here. So I'm going to go from here to positive. Again, that's going to be red. I'm going to go from negative to here, and that is going to be black. Now I'm going to start my simulation. Still not getting the right answer. What's up with that? All right, I know what I'm doing wrong. So again, I've created a parallel circuit through this multimeter. So what I need to do here, good thing I'm going through this before you guys do. I'm just going to get rid of that, okay? So I guess realistically here, check your resistance first, make sure it's right, get rid of it, start checking your amperage. Now, when we run this, we are reading 9.98 milliamps. We have calculated the fact that we are supposed to be calculating 10 milliamps, 9.98 rounds to 10, close enough. You know, there is some added resistance of the wire itself, which is probably what that thing is picking up. But that's good, okay? So that's example number one. We're going to run through example number two a little faster than this, and then call this a done tutorial here. So we have a parallel circuit. We have two 500 ohm resistors. So the shortcut here for measuring or for calculating resistance total here is, because they're the exact same value, electrons are going to split in half. 500 times 0.5 is equal to 250. So that's our total resistance in that case, okay? So for example 2, resistance total is equal to 250 ohms. E total is still equal to 9 volts. We're still going to take 9, but this time we're going to divide it by 250. and we are coming up with I total 0.036, aka 36 milliamps. Okay, so my calculated resistance would be that, my calculated current would be that. So again, here I have two 500 ohm resistors. Just jotting that down so I know when I go through my circuit here. So let's get rid of these wires. Let's change this value to be equal to 500, which it already was, honestly. Let's change this to be equal to 500, not kilo ohms, so 500 ohms. Let's get rid of this. Okay, so we're going to put these two circuits in parallel. And again, if we wanted to check our resistance, let's start our simulation, 250 ohms. So we would jot that down in the measured category. Then we're going to go through and we're going to connect these things up to power down here. So that's going to be black. That is going to be red. Okay, and again, if I were to just connect these things in parallel, it wouldn't work. It would give me that too high thing again. So once again, what we're going to do is put the multimeter in the circuit in series. So here, I'm going to come back down. This is going to be black. So let's follow the electrons. Electrons are coming out of the negative. They're coming through here. Now they're in here. They can either go down this or this. Then they're going to come back again to the black terminal. And they're going to shoot up to our ammeter, which I still need to change, back through the positive and back to that positive pole here. Okay, so we still have a parallel circuit for our resistors, but our multimeter is now in series. And talking about multimeter, I need to turn that into an ammeter. I'm going to hit start. And once again, we're measuring 35.8 milliamps. And again, I calculated 36 milliamps. So once again, we round that and it's the exact same thing. All right. So I hope that this helps you guys go through this lab. We'll be talking about this in class some more too, but this is if you still have questions after class and you're working on this, you'll be able to go through sections of this video here. All right. Okay. Adios.